page 11 in your notes. And today we're going to look at some stuff that's familiar and some stuff that's a little new. So today we're going to focus on measures of center and measures of spread. Measures of center are where we're looking at some of those statistical measurements or those calculations that we do when we want to look at where the middle of our data is. So that would be things like median, right? Median is where we find the middle. And things like mean. Unless I've got some really crazy values thrown in there, mean is usually a fair indicator of the middle of my data. And then we're also going to talk about measures of spread or measures of variability. One measure of variability that we are already familiar with is range. So we're going to see a little bit different type of range today. And then we're also going to see something called deviation. And we'll talk about deviation some more a little bit later this week. So to start, since we've already talked about mean and median, I want you to take a look at problems 1 through 4 at the top of page 11. Problems 1 through 4. Give those a try. You are probably going to want your calculator handy for today, so if you don't already, I would get that out. Our first question here asks us basically how we find the mean of a set of values. So this says the mean can be found by adding all the numbers in a data set and dividing by the number of numbers in the data set. True or false? When I find the mean, I add up all the numbers and then divide by how many numbers I had. Yeah, that's true. For our dot plot down here at the bottom, is our mean 4? So I would add up 1 plus 2 plus 2 plus 3 plus 3 plus 3 plus 4 plus 4 plus 5 plus 6 plus 7 plus 8. And I would divide by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, we would get a mean of 4 there. How about for my data set here, the median? Is the median of this set 9? No, 9's in the middle, so why isn't that the median? Yeah, I have to put my numbers in order first. So 1, 4, 5, 9, 10. Our median here would be 5, so this is false. And then for our dot plot, the median for our dot plot. So we've got 1, 2, 3, 1, 2, 3, 1. We'll just go by ones here. 1, 1, 1, 1, and I've got 2 in the middle. Would my median, the middle for those be 3.5? Yeah, remember if I've got 2 in the middle, my median is the average of those. So this would also be true. So this is all stuff that we've talked about before today. This is all review, refresher. So we're going to spend the rest of our class time focusing on some new things, okay? We're going to use the same skills that we looked at for our warm-up. So we're going to have to find the mean a couple times today. We're also going to look at finding the range, which I know we didn't do in here, but remember the range is just our maximum value minus our minimum value. So we're going to use those same ideas, those things that we're already familiar with, to look at a couple new options for ways that we can consider or look at our data. So on the bottom of page 11, the first new thing we're going to look at is something called IQR, or interquartile range. Remember when we were creating box plots, we had to find those quartiles, right? We took our data, we cut it in half, and then for each half, we cut those in half as well. So we split our data into fourths, right? Quartile, quarter, fourth. So we're going to do that here. So here's our data. These are heart rates of 8 high school students listed in beats per minute. The first thing I want to do here is put my data in order. So my smallest value is 72, and then 75, then 76, 76, 77, 78, 79, and then 81 finally at the end. And I'm going to pretend for a second that I'm going to make a box plot. Okay, I'm going to go through that same process I did when I was trying to make a box plot. So the first thing I'm going to do is split my data in half. I'm going to find the median. 1, 2, 3. My median would be here, between those two. So that would be 76.5 would be our median. And then I need to find those quartiles, Q1 and Q3. So in the lower half, I'm going to find the middle here. That would be right here, between 75 and 76. So that would be 75.5. There's my Q1. And then I've got to split the upper half of my data. So again, I want to find the middle. Be here, 78.5 would be Q3. Now I've split my data into fourths. My interquartile range refers to the range between my quartiles. Okay, that's all that means. Interquartile range is the range between the quartiles. So for range, regular range, we would take that maximum value and subtract the minimum value. For interquartile range, we're going to take our Q3 value and subtract our Q1 value. So this would be 78.5 minus 75.5. That gives us an interquartile range of 3. The interquartile range is telling us for the middle 50% of our data, those values are at most 3 units apart. In this case, 3 beats per minute apart. So for that middle chunk of my data, the middle 50%, okay, they're at most 3 apart. Questions for me so far? Okay. So remember that when we split our data into these quartiles, we're splitting it in fourths. So I should not be surprised that I have the same amount of values in each of these sections, right? I took 8 things and I split it into 4s, right? Split it into fourths. So for number 2, this is kind of just reinforcing that point. How many values in my data set are less than Q1? Well, here's Q1. How many are less than? Well, 2. How many are between Q1 and the median? Also 2, right? All these should be the same. How many are between the median and Q3? Again, 2. How many are bigger than Q3? Again, 2. I split it into 4 equal parts. So I should get the same amount of data in each of those sections. I should have the same number of values in each of those sections. Now that interquartile range, remember, is 2 of those fourths, okay, or a half. So how many values are between Q1 and Q3? 1, 2, 3, 4. Since it's 2 quarters, it should be double what's in a quarter. Does that make sense? Okay. Questions for me on interquartile range? Not too bad? Okay. So the next thing we're going to look at is another measure of variability, something called mean absolute deviation. Okay, mean absolute deviation. We're going to use the same information, that heartbeat data that we used on that last problem. I'm going to talk about deviation for a second. So the idea behind deviation is we're looking at not how far, so for range, we're looking at how far apart could I at most be for these middle 50% of values. For deviation, we're looking at on average, or what would I expect an individual value to be different from the mean? How far apart are these individual values from the mean? Okay, usually on average, if we're looking at mean absolute deviation. So we're going to look at, again, mean absolute deviation today. A little bit later this week, we're going to look at something called standard deviation. Standard deviation is sort of more commonly and widely used when we talk about statistics. So in Algebra 2, when we look at our statistics unit, we're going to talk a lot about standard deviation. If you choose to take dual credit stats as a senior, you're going to see standard deviation in there as well. It's another sort of option that we have for figuring this difference, okay? When we talk about standard deviation, you are going to want your calculators. What we're going to look at today, we can do on our paper with your calculator on your phone if you needed to. But what we're going to look at on Friday, standard deviation, you need your TI Inspire calculators, okay? You can't do it by hand. You won't be able to do it on your phone. We need some features that are on your TI Inspire. Okay, so make sure you bring those calculators for Friday. So on page 12, mean absolute deviation, okay? Same data as our last problem. The first thing I want to do here is find the mean for this set of data. So I would like you to do that for me now, please. Find the mean of these values. Find that mean. Anybody find our mean yet? You know? Yep. 76.75 is our mean. I have a table here formatted for us to make this next few steps we're going to do a little bit easier. So I want you to please fill in the mean for every spot in this column. So I'm just jotting down the mean. And now what we're going to do is figure out how much each individual data value differs from the mean. So to do that, we're going to take each data value and subtract the mean. Okay, and that will give me its deviation. So data value minus the mean. I want you to do that for each line of this table. Data value minus the mean equals what? You're going to get some negatives. That's okay. Data value minus the mean. So what we see in this deviation from the mean column is how far below or above each individual data point is from the mean. Okay, it should make sense here that we've got some negative values and some positive values, right? When we talk about comparing these values to the mean, right, mean or average, we should have hopefully that mean kind of towards the middle of our data. So I would expect some values to be lower, some values to be higher. If it's smaller, I would get something negative. If it's bigger than the mean, I would get something positive. Now what I want you to do is take the absolute value for each of these. So if it's a negative number, you're going to get something positive when you take the absolute value. If it's already positive, it's going to stay the same. Go ahead and fill those in for me. And now what I want you to do is find the mean of these guys. Find the average of this column. Anybody have that average yet? Rachel? Really close to 2, right? I think it's 1.9375, like just a hair under 2. So here's what this tells us. Okay? Here's why we care about this number. What this tells us is that on average, our values should be, our data values should be within about 2 of the mean. Now we know we've got some values that didn't fit that, right? This guy, 72, was outside that range. But this guy was within 2. Here we've got another one that was outside that range, but this guy was within 2, this guy was within 2, this guy was within 2. This guy was outside, but like just outside. And then this guy was within 2. On average, most of our values should be within this amount of the mean. For those values that fell outside of that, that's where we start to look at, well, is it just a little outside and I would still consider it pretty cohesive with the rest of my data? Or is it so far outside that maybe this value that I have isn't really representative? Maybe it's what we would call an outlier. So I want you to notice that for our first value, 72, this deviation for 72 is more than twice that average. We see that? And the same thing for our deviation for 81, okay, our lowest value and our highest value here. Its deviation is more than twice that average deviation that we found. So this is where we might start to ask ourselves, are these values still representative? Or did I get values that like are really kind of skewing my results? Are these so far outside of that deviation, that average deviation, that they actually really aren't maybe good sample points to have in my data, okay? And we'll talk more about that later this week, but that's what we want to start thinking about with these deviation numbers, okay? It gives me an average for how far away most points should be from my mean. So I would expect most of my values to be, again, no more than this far away from the mean. If they're a lot farther away than this, that's where I want to start asking those questions. Okay. Questions on that example 2 problem up at the top. Okay. So let's take a look at interquartile range, median, and mean absolute deviation with one more different sort of type of problem. So down at the bottom of page 12, we're going to do one more example together. The context for this problem is that we're looking at a pod of dolphins that has 800 dolphins and there are various ages and lengths. And we found that the median length of our dolphins for this pod is 5.8 feet. 5.8 is our median. Remember, median is middle. So I want to know, what can I say about the length of my dolphins if I know the median? So I want to flip back for just a second to where we found the median for our heart rate problem. Remember, the median cuts my data in half. So when we found the median of our heart rates, we had heart rates below that and heart rates above that. So if we talk about the median for our dolphins, what would I expect for the length of those dolphins? They're going to be what? Yeah, those lengths should be above and below. And remember, it cuts my data in half. So I should expect 50% of those dolphins, 50% of dolphins should be longer than 5.8 feet. And then the other 50% should be shorter than 5.8 feet. That median cuts our data in half, right? So I'll have a short half and a long half for my dolphins. Now for B, we're looking at IQR, that interquartile range. This says the IQR of the length of the dolphins is 4.2 feet. So what does that tell me about dolphins? So I know I've taken all my dolphins and basically split them into fourths, right? We know the median is 5.8, and then we split each of these in, I've got Q1 and Q3, and it doesn't tell me what values I associate with Q1 and Q3, but I know that the difference between them, the range between these, is 4.2. So again, we found that with our heart rates problem on the last page. I'm going to flip back again. We said that that interquartile range was 3. So if I took Q3 and subtracted Q1, I got 3. And that meant that for that middle 50% of heart rates, the ones in the middle, those middle 2 quarters, they should be no more than 3 beats apart. Bless you. So if we flip back to our dolphins, I should be able to say something similar in regards to their lengths. So that middle 50% of dolphins, those middle 2 quarters that we're looking at, the middle 50% of dolphins are within 4.2 feet in length of one another. The biggest difference I could have in length for those middle 50% would be 4.2 feet. Everybody else, their difference in lengths should be shorter than that. And then our last question here, it says the mean absolute deviation for the dolphins is 1.3 feet. So what does this tell me about my dolphins? Now remember up here, our mean absolute deviation told us that on average, most of our values should be within this amount of the mean, within about 2 of the mean. So that would be the same thing for the dolphins. I don't know what the mean is. That's fine. I don't need to know what the mean is, but I know that they should all be within 1.3 feet of it. So on average, most dolphins are within 1.3 feet of the mean length. Questions for me on median, interquartile range, mean absolute deviation? Anything that we looked at for today? Okay. So your homework for today is on page 13. I just want you to worry about problems 1 and 2. So you have a data set. I'm asking you to find a couple of measures and then tell me what they mean in the context of that problem. So similar to what we just did with our dolphins, okay? Just 1 and 2 on page 13. There's a list of some Khan Academy exercises at the bottom. You do not need to worry about those for tonight.